Hi ma, good morning to everyone. Okay, today class, state the working principle of potentiometer. State the working principle of potentiometer. So potentiometer is used to find the potential difference between the 2 points. Okay, so here first state the working principle of a potentiometer. Explain with the help of circuit diagram how the EMF of two primary cells are compared by using the potentiometer. In this question, first we can write the principle of the potentiometer and then take the two EMFs and draw the circuit diagram of the potentiometer and compare the two EMFs. Okay. So for this purpose, first we can write the principle of the potentiometer. So principle is nothing but the potential difference epsilon between any 2 points of a wire. The potential difference between any 2 points of a wire is directly proportional to the length L of the wire between the 2 points. The principle is nothing but the potential difference between any 2 points is proportional to the length of the wire between 2 points. Length of the wire between the 2 points is called the principle of the potentiometer. That is nothing but the potential difference is nothing but epsilon, which is proportional to length of the wire. That means epsilon is proportional to L. That implies epsilon equal to phi L. Here comparison of EMFs. Okay. Comparison of EMFs of a two cells. For this purpose, firstly we can draw the circuit. This is the circuit diagram. Observe it. This is the potential. We can take the potential epsilon and this is the rheostat. RH indicates RH slash rheostat. Okay. Not a resistor, rheostat. And this is the key point. This is called primary circuit. Okay. Primary circuit contains epsilon and rheostat and the key. Okay. And second one, this is the secondary circuit. Here we are taking the two EMFs for comparing those. Okay, epsilon 1 and epsilon 2 are the two comparing EMFs and these are the points 1, 2, 3, 3 key points. Here observe, we can connect 1, 3 points. That means the switch is closed. The switch is closed means these 1, 3 points are connected. Then the EMF epsilon 1 will be connected to this is the galvanometer G. Okay, galvanometer G. And 2 is switch off mode. Okay, switch off mode and this is the switch on mode. For example, we will connect the 2 and 3 terminals. That means the epsilon 2 will be connected to galvanometer. This is the process. This is the key points. Okay. Initially, for this purpose, we can calculate or compare the epsilon 1 and epsilon 2 EMFs. Okay. So, for this purpose, comparison of EMFs of a two cells, let epsilon 1 and epsilon 2 be the EMFs of the two cells under comparison. If the first position of the key points, if the first position of the key will be points to 1, 3 points are connected, cell of epsilon 1 connected to the galvanometer. So, we are connecting these 2 points 1 and 3, then the epsilon 1 will be connected to galvanometer G. So, now the balancing length L1 can be mentioned with L1 is epsilon 1 equal to phi L1 is the epsilon 1 equal to phi L1. Here we are connecting 1 and 3 points, we are using here epsilon 1 equal to phi L1. And in the second position of the key points, 2 and 3 are connected, then epsilon 2 will be connected to galvanometer, then the length of the wire is L2, then epsilon 2 will be equal to phi L2. This is equation 1, this is equation 2, 1 by 2 implies epsilon 1 by epsilon 2 equal to phi L1 by phi L2. Then we will get epsilon 1 by epsilon 2 equal to L1 by L2. We will compare their EMFs. Therefore, their EMFs epsilon 1 by epsilon 2 will be equal to length L1 by L2. Okay, got it? Once I will repeat it. So, initially first here we are observing the circuit diagram, we are taking the EMF epsilon and rheostat and key, that is the primary circuit, and secondary circuit contains two EMFs and galvanometer key. Galvanometer measures the current reading. Okay, first we have 1, 2 are the terminals of epsilon 1 and epsilon 2 and third terminal is the galvanometer. Okay, this is our circuit diagram. In the J is the jockey connected. Okay. And here first the principle of potentiometer says that the EMF of the voltage or the potential difference between any 2 points is directly proportional to the length of the wire. Okay. That is the principle of potentiometer. That means epsilon is proportional to L. That implies epsilon equal to phi L. Now comparison the EMFs of the two cells. For this purpose we are taking two EMFs, epsilon 1 and epsilon 2. In this first we are connecting the point epsilon EMF epsilon 1 to the galvanometer. That means we are firstly connected 1 and 3 terminals. Then we will get the epsilon 1 will be connected to G. Then the length of the wire will be written as epsilon 1 equal to phi L1. That is equation number 1. And next we will connected the second connection, that is epsilon 2 to the galvanometer. That is we are joining the 2 and 3 terminals. Then we will get the epsilon 2. Epsilon 2, the length of the wire becomes epsilon 2 equal to phi L2. This is equation number 2. Then we will compare the EMF. For this purpose 1 divided by 2. That means epsilon 1 by epsilon 2 equal to phi L1 by phi L2. Therefore epsilon 1 by epsilon 2 equal to L1 by L2. This is the question. Okay. Statement of the potentiometer and the comparison of EMF on the circuit diagram of the potentiometer. Okay. With comparison of the two EMFs. And next we will discuss the next question. The next one is state the working principle of potentiometer. Explain with the help of the circuit diagram how the potentiometer is used to determine the internal resistance of the given primary cells. You can calculate the internal resistance of the primary cells. For this purpose, first we will take the diagram, same similar diagram in previous class. So this is the epsilon rheostat and P K1. This is the primary circuit and this is the secondary circuit. In this very small modification, before that we will take epsilon 1 and epsilon 2. Why? Because we are taking comparison of two EMFs. Here we will take epsilon and resistance box and extra K2 key. Okay, here two keys, K1 and K2 keys. Okay. So the principle of potentiometer is nothing but the potential difference between any 2 points will be proportional to the length of the given wire. So for this, epsilon is proportional to L, epsilon equal to phi L. Here phi is nothing but a potential drop per unit length of the wire. Next we will calculate the determining internal resistance of a cell. For this purpose, the cell of EMF epsilon whose internal resistance R is connected to key K2. This is the internal resistance box. Here is the resistance which will be connected to key K2. First the key K1 is closed and K2 is open. Now the K1 is closed and K2 is open. For this, now the length of the wire L1 is noted. That is nothing but epsilon equal to phi L1. K1 is closed and K2 is open. Okay. So then phi epsilon equal to phi L1. Now K2 is closed. Now balance the length L2 of the wire is noted. The terminal voltage is given by V equal to phi L2. Okay. So 1 by 2 equation is nothing but V here voltage drop. V equal to phi L2. Then from 1 and 2 we can write epsilon by V equal to L1 by L2. This is equation number 1. But everybody knows epsilon equal to I into, that means V equal to IR condition. In this the epsilon here epsilon equal to I into R plus R. Okay. R plus R and V equal to IR potential. So from these two equations we can write epsilon by V equal to L1 by L2 and epsilon by V equal to R plus R by R. So epsilon by V I into R plus R by IR. IR cancel out the R plus R by R. From equation 3 and 4 we can write R plus R by R equal to L1 by L2. On simplifying this we will get R equal to capital R into L1 by L2 minus 1. This is the resistances of the given primary circuit. Once I will repeat it, first we can write the principle of the potentiometer and resistances of the wire by using the circuit diagram. First we can draw the diagram, primary circuit and the secondary circuit. In primary circuit we have rheostat, key 1, key K1 and epsilon. And the secondary circuit consists of the epsilon and the key K2 and resistance box galvanometer. Galvanometer is used to calculate the current. Now the potentiometer, principle of the potentiometer says that the potential difference between any 2 points is proportional to the length of the given wire. That is epsilon is proportional to L. That implies epsilon equal to phi L. Phi is the potential drop per unit area of the wire. First we will consider the key K1 is closed. K1 is closed means it will be connected and K2 is open, it is connected. So for this purpose first we will get EMF epsilon 1 equal to phi L1. Next we will connect K2 is open, K2 is closed and K1 is open. Then we will get the voltage V equal to phi L2. But we have the values epsilon by V equal to L1 by L2. But we have the values I into capital R plus small r, that is nothing but a V equal to I R formula. Combine epsilon by V equal to R plus R by capital R. By using these two equations, we will get R plus capital R plus small r by capital R equal to L by L. So simplifying these two, we will get R by